Welcome to clickmateprojects.com. Here we are going to discuss about dental radiographs and photographs in human forensic identification, biometric identifiers, specific physical, physiological and other measurable characteristics unique to each individual have been widely used as tools in forensic identification. Although some biometric identifiers can result in an excellent match, for example, fingerprint and DNA, they are affected by early tissue decay and as such and are not always suitable or appropriate for post-mortem identification. Unlike many other biometric identifiers, teeth are capable of withstand extreme conditions, making them an fitting choice for identification is in the case which involving advanced decomposition. Numerous studies have underlined the importance of dental records in providing fast, reliable and inexpensive means to human forensic identification. However, dental identification in the context of mass disaster situation and missing person cases can be both time consuming and cumbersome due to the large number of victims. Consequently, in an attempt to automate the process of forensic identification, several programs have been developed and widely used. These systems carried out an identification process through a comparison of AM and PM data, including fingerprints, data records, DNA, medical details, belongings, and physical descriptors. It is important to note that the search engine does not directly use the dental radiographs. Instead, forensic odontologists examine the radiographs and for each individual tooth they character, chart or encode morphological features such as dental morphological work, pathology and dental restoration, presence or absence of tooth, presence or absence of restoration and other anatomic characteristics. The resulting dental codes along with physical descriptors and they considered by a single text-based research algorithm. Despite their success, currently employed text-based research approaches have many limitations. Coding of dental features is done manually, making the entire process error-prone. Even a single typographic mistake can limit the search engine's ability to find the correct match. Subsequent interpretations of X-rays poses another problem as it can result in observational findings that might not necessarily be agreed upon by all odontologists. Furthermore, dental codes only capture artificial dental work and ignore characteristics inherent to teeth such as crown and root contours. Here in this paper, we extract the dental features by using the shift algorithms and finding the matches, and finally we recognize the person who has the matching to the database. Now I am going to explain the flow diagram of our project. In the first stage of our flow, we give the X-ray or original image of the input dental images, and from the dental images we first load as the pre-processing stage. In the pre-processing stage, each and every pixels can contain the many number of noisy pixels. The noisy pixels can be removed by applying the filtering process in the given images. The given images are formed as a matrices, and for each and every pixel regions, it checks whether there was any noises present in that pixel regions or not. And finally, according to the filtering, it limits the unwanted pixel areas which are present in the image and remove it and allows only the wanted or original image pixel. And finally, this filtered images was fed to the enhancement stage. In the image enhancement stage, it normalizes the histogram level of that image. So to normalize the histogram level of each and every pixels, it first extracts the histogram features and then checks whether there was more low values and more high ranges. So for that each and every iterations it checks the total variations in low level and high level, and it will makes the limitations for both the cases of low level and high level, and finally we get the enhanced images from the preprocessor stage. And after that we segment the dental images. In the segmentation process we segment the ground truth effect and from the original images and extract only the tooth images from the given image. And after that image segmentation we extract the features by providing the morphological operations of given image. So after segmentation process we get the binary data of the segmented area, and after segmented area we make a counter effect which represent the segmentation's outer border, and then we generate the binary images which are made as a segmentation process and make an morphological operations to provide the skeletonization operations of the given binary images and make them to provide as a feature vector. After that extraction of feature points, we first checking the matching points of database which are made by using shift features. According to the shift features, it checks the each and every point with regarding to the database points and check whether the feature points matchings to the database for the given images or not. So the maximum matchings from the database will be collected as the recognized image. Finally, we recognize the matching tooth database. Now I am going to explain the running procedure of our project. In our running process, we make a guide design. So just open the main pgm.m file by right click it and press run file. Here it will display the guide designs of our proposed architecture. The buttons or make the to activate the each and every process. In the first stage, we load the input image by click open image. Here we make the database. In this database we can extract the any other image. Here the axis will be displays the selected images. And after selecting the images, we made the segmentation process to extract only the tooth images by clicking segment image button. This will display the original image and the segmented area of tooth region. After the tooth segmentation, we make a contour to provide the outer border of the segmented area. This will make the depth regions which are matching to the given image database, and finally make the red lines which representing the contour making of segmented area. After that, it provides the morphological operations. The morphological operations here we done is the skeletonization process to extract the features of the given segmented area. This will representing as a binary image. So the binary images will be combined, and this was formed as a line diagrams. These line diagrams are combined as an x direction and y direction matchings, and finally this was created as a database. And from this database, this was matchings made by using shift feature. By click the recognition button, it checks each and every operations. Then finally, it gives the recognized result as a message box. Thus we recognize the given input data by using the photographic or either the X-rays images. Thus we identify the forensic images from our given database. Thank you.